Now let us see next article in the chapter three-dimensional geometry, line. You have already studied line in different standards. You know different equations of lines. General equation of line ax plus by plus c equal to 0, where a, b, c, they are real numbers, and either a not equal to 0 or b not equal to 0. Degree of linear equation is 1, and every linear equation represents a line. Similarly, we have seen equation of line y equal to mx plus c, where m is slope of line, c is y-intercept of line. So this is equation of line in slope-intercept form. But now we have to study line which is in space. Now these are the equations of lines which are in plane, two-dimensional geometry. So we have to study line in three-dimensional geometry, and we shall see equations of lines in vector form. If we know a point in space whose position vector known, suppose A is any point in space whose position vector A bar, and another vector B bar, it is parallel to the line, then we can write equation of line. For that, consider three axes which are mutually perpendicular to each other. X-axis, y-axis and z-axis. Point of intersection, origin. So A is any point in a space. Position vector of point is given. Generally, position vector of point is denoted by small letter. So position vector of point A bar. And position vector of a point, it is vector directed from origin towards point. Position vector of point A, vector directed from origin towards point A. And B bar is a vector which is parallel to line passing through point A. Suppose this is a line which is passing through point A, and B bar, vector parallel to this line. On the same line, consider any other point other than A. Suppose R is a point on the same line, and usually position vector is denoted by small letter. So we shall denote position vector of point R by R bar. It is a vector directed from origin towards point R. A and R, they are the points on the same line. AR bar, vector directed from point A towards point R. This is vector in space. Now as B bar is parallel to line, means AR parallel to B bar. So we can write AR bar parallel to B bar. As line is parallel to B bar, this vector along this line is also parallel to B bar. And we have already seen that when two vectors are parallel to each other, we can express one vector as scalar multiple of other. Suppose lambda, it is a scalar quantity, and it is a scalar quantity such that AR bar equal to lambda B bar. So when two vectors are parallel, any one vector can be written as scalar multiple of other. Here lambda, it is scalar quantity, real number. Now AR bar, vector in space. It is a vector directed from point A towards point R. Here A is initial point, R is terminal point. And vector in space can be expressed as position vector of terminal point minus position vector of initial point. Position vector of terminal point R, R bar, minus position vector of initial point A bar, equal to lambda B bar. So this may be written as R bar equal to A bar plus lambda B bar. Now this is equation of line which is in space. Equation of line in vector form. And in this equation, lambda is a scalar quantity, or we may say lambda is a parameter. So this is equation of line in vector form, and that vector form is parametric form. So when we know any point in space with its position vector and vector parallel to line, then we can write equation of line in vector form. In this equation, lambda is parameter, so we can say this is equation of line in parametric form. We know to specify position of a line, we should know one point and direction of line. So if we know coordinates of one point on line and direction of line, position of line is specified. Or if we know coordinates of any 2 points on the line, then also we can specify position of a line. If 2 points on a line are known to us, then its direction, it is automatically decided. Now this is equation of line which is in space in vector form. Same equation can be written in another form also. Suppose A is point in space whose coordinates are known, x1, y1, z1. Three coordinates are known. So this is a point in space. And if direction ratios of line are known, suppose direction ratios of line are A, B, C, then also we can write equation of line. Then equation of line, it is given by x minus x1 upon A equal to y minus y1 upon B equal to z minus z1 upon C. When coordinates of point in space are known to us and direction ratios of line are known to us, then we can write equation of line. And this equation of line, it is in Cartesian form. Now, from coordinates of point and direction ratios of line, we can write equation of line in vector form also. But for that, we have to find position vector of point. When coordinates of point are known, position vector of point, in that coordinates of point, they become coefficients of unit vectors I, j, k. Now I, j, k, they are the unit vectors along positive coordinate axis. I, unit vector along positive x-axis. J, unit vector along positive y-axis. K, unit vector along positive z-axis. Position vector of point A, we get x1i plus y1j plus z1k. If direction ratios of a line are known to us, we can write vector passing through that line or vector parallel to that line, because direction ratios of parallel lines are same or proportional. Suppose B bar is a vector parallel to line passing through A. When direction ratios are known, direction ratios, they become coefficients of unit vectors. So we get AI plus BJ plus CK. And as we have written position vector of point in space and vector parallel to line, we can write equation of line in vector form also. If we know coordinates of point in space and instead of direction ratios, if we know direction cosines of line, then also we can write equation of line in Cartesian form. Then equation of line, x minus x1 divided by L equal to y minus y1 upon m equal to z minus z1 upon n. If we compare this equation with this, we can observe that numerators are same and denominators are proportional, because direction ratios, they are the numbers which are proportional to the direction cosines of the line. So instead of direction ratios, even if we know direction cosines, then also we can write equation of line in Cartesian form.